Hello students, welcome to the standard 12th mathematics chapter 1 relations and functions. So as we have seen 11 examples before this lecture, so we will continue now in forward. This is example 12, and in this what we want to do, show that function n to n given by fx equals to x plus 1 if x is odd and x minus 1 if x is even. And this both the functions we want to do that 1 1 and onto. This function we want to do it is 1 1 and onto both. For this the solution is that here we are given this function f from n to n. In that first we will take first part of it, fx equals to x plus 1 if x is odd. Fx equal to x plus 1 if x is odd. First part we have taken. X is odd, that is x equals to odd numbers in natural numbers only. 1, 3, 5, 7 and so on. So 1 by 1 if we place here in this function with this condition, x equals to 1 we can place first. f1 equals to 1 plus 1 equal to 2 we will get. If we take the second value 3 here, f3 equals to 3 plus 1 will give 4. If we take the third value f5, it will give 5 plus 1, 6 in this one. So here, what is the conclusion? That fx, any value of x we place, we get x plus 1. And this answer always you can see 2, 4, 6 means even. Forward, when we place next to next values, we will get all even numbers. So we have done even E for evens. Right? If you make the functions picturization or figure like this, in this we have the elements are from natural number. In this odd are 1, 3, 5, 7. So we have placed here in x belongs to n. All odds we have 1, 3, 5, 7. Here we have placed all the elements in the domain. Here in codomain what we are getting 2, 4, 6 all evens we are getting. So 2, 4, 6 all evens we have shown here. Y belongs to an all evens coming. As we have seen in this function that for 1 this image is 2 we are getting. For 1 the image is 2. For 3 the image is 4. For 5 the image is 6. And so on. For all odds we will get its images all evens. Now we take the next part of it. First part we are seeing here. Next part of it. For f function f from n to n, fx equals to x minus 1 if x is even. X minus 1 if x is even. And we know that even, that is 2, 4, 6 and all even numbers. We place this as in this function given. F first even is 2. f2 equals to 2 minus 1 will give 1. Then next f4 equals to 4 minus 1 give 3. Then f6 equals to 6 minus 1 give 5. So what is the conclusion here? In this function fx equals to x minus 1, whatever the answers are coming, they are all odds. For that we have written O for odds. Okay. And for this also, for this part also, second part also, we draw here the figure like this way. Here all the elements of domain are evens. So domain elements are x belongs to n evens we have shown here in domain place. 2, 4, 6 and so on, all even numbers. And their images we are getting here 1, 3, 5 and all odds we are getting. So here in codomain we have shown y belongs to n odds 1, 3, 5, 7 and all odds here. For every odd we are getting distinct and unique images and they are odds. That's why here written for every element x belongs to n. If we combine both of this, you can see here for every odd the images are evens. Here we can see for every even the images are odds. So in natural number, for all combining this, for all the every elements of natural number here in domain, we are finding their images in codomain. If we combine both of this, so what we can say here, for every element x belongs to n, there is unique and distinct images y belongs to n. What it gives us idea? It is giving that for every element we are having the distinct and unique images. So what it concludes that f is 1 1. F is 1 1 function. Similarly, for every image, if you think about, these are all even images. For there they have their unique and some elements in domain. For here also, for every odd images we have some element in domain. They are given. So what you can say, for every image y belongs to n, there exists some element x belongs to n. And by definition, what it shows? It shows that f is onto also. So what was we are doing here? F is 1 1 as well as f is